Ladies and gentlemen, please eject your chewing gum, especially we can start with a video. Hello and welcome to another Solana tutorial. Today we're gonna have a look at the program metadata program, which is a program that stores program metadata, which is not confusing naming whatsoever, but we will understand, no worries. Basically, it's a program that handles things like storing IDLs for other programs, because it is good practice to upload your IDL on chain such that everybody knows how to interact with your program. Unless you specifically don't want that, then you specifically don't do that, but good practice would be to do that. Good practice would also be to create a security TXT such that people, especially security researchers, can contact you if they find bugs in your program. Because since everything is, decentralized and anonymous, it's difficult to find the owners of a program, and everybody can deploy a program and there's no email addresses or whatever. So yeah, that's also good practice. So you want to do that, and today I want to have a look how we do that with the program metadata program and understand how it stores metadata such that we can also read IDLs from on-chain programs and publish our own ones. That's the goal, so let's get to it. Can't be so difficult, right? Solana program metadata. That's it, I think. Built by Jonas and others. Yeah. Attach custom metadata to any program. The program metadata provides the ability to attach metadata information to any program. This information is represented by a PDA account with a predefined derivation. So it can be used to add the IDL of a program with a PDA using IDL as a seed. That makes sense, right? So if you want to store stuff for a program, you just create a PDA with the program key and the seed, in this case a IDL. There are two types: canonical, these are created by the program update authority and they derive program key seed, and non-canonical, third party, so anybody can create metadata for any program, but then they're non-canonical, where you then also put the authority key as a seed for the PDA. Okay, there can only be a single canonical metadata account for any program and seed pair. That makes sense, because any one program for any one seed, like IDL, there can only be one. Hence, canonical. We know that word from the canonical bump, which is the first valid bump. When you find a program address, you go through bumps 255 to lower, until you find one that creates a PDA that actually doesn't live on curve. And the first one for which that is true is called the canonical bump. And the same idea here. So yeah, canonical, there can only be one. Then they also want to allow for anybody to create metadata for any program. And the metadata is either saved on chain in an account, or it can be saved to a URL or another account. Okay, we will understand what that means. So we can upload IDL and security TXT. So this Solana program metadata, that's this repository, that thing has a CLI, and we can directly use it with npx, or we install it and then we can use it like that. But I like npx, let's do it like that. Let's try that. And before we can try that, we probably need a program. Let's create a program. Program metadata program. PMP. Dynamite, it's PMP. I win that fight, cause it's PMP. I'm a powerhouse. Watch me expose my IDL. Last time we saw Anchor automatically doing that. So let's create an Anchor program. Anchor init, I don't know, demo program. Then we have a demo program. I want a nicer key. This is gonna be my program ID. And then I'm also gonna copy that to my demo program target deploy key pair. Okay. And while we're here, there we go. And we Solana config set to devnet and use this authority. There we go. And Solana airdrop myself some Sol or not. Give me 5 Sol this time. Cool. Got some Sol to deploy. And then I'm gonna tell you, hey, can we please use devnet and, oops, that's the authority. And this wallet and this program ID. And can you put seeds in the IDL? Okay. And then we create a simple program. Basically, it doesn't even need to do much. I just wanted to have some instructions like Look, mom, it has an instruction. Yeah, whatever. It doesn't matter. Just give it that one instruction. It's just about the demo. Look, I just want to be able to build this such that it creates an IDL. I'm not actually intending to run this program. Okay, so we have the program and now the IDL. Boom, here. So we have an instruction. Look, mom, it has an instruction. That's the discriminator. Wonderful. Doesn't take accounts, doesn't take arguments. Simplest program you could possibly do with Anchor. I just want the program that has an IDL. So now check this. If I tell it to Anchor deploy, what? Can't connect to DevNet. Oh no, that's not good. Let's pretend that didn't happen and try again. No, mother. No default signer. Do I have a space in here again? I have a space in here again. Classic. Keeps happening. Okay, but now, okay. Then first of all, it actually deploys my program in 200 transactions because Anchor's big. And then it writes the IDL data, which is 224 bytes. And the IDL is created here. Okay, first of all, why 224? Probably because if we remove all the white spaces, there we go. That looks better. So if I remove all of the white space stuff, then this thing will have 289. Interesting. So I wonder what's still the difference then. Or it's storing it in a different format. I don't know. But it's ballpark that area. If I would show you here, that's the number of characters in this file after white space removal. So maybe it still optimizes that a bit. Who knows? We will see. But anyway, it created this account. So let's check this account. Allocated data size is actually 492 bytes. There we go. So that's bigger than the 224 bytes. Assigned program ID. Why did it assign it? Wait, what? No, hold on. 5E3. So that's my program. That's the executable data of it. That's the update authority. I'm confused why it says assigned program ID. Is that just the Explorer telling me something? Wait, let's check it with Solana account. There it will say, yeah, indeed, the owner is still the demo program. So maybe that's a different way of doing things? Maybe that's not using the program metadata. Maybe that's a different strategy, because here I would expect that you create it for this program, or maybe that's not even a program, but no, it is. Look, obviously, because it needs to somehow store stuff. But it doesn't make no sense to have the owner be the program itself, because then you can't change that account anymore. You can't update the IDL anymore if this program is the owner, unless this program would write to it. That's weird. But maybe Anchor does that differently. Maybe that's a different way of doing things. Let's see. If I were to check for that program, if it has any program IDL, then it tells me yes. Look, mom, it has an instruction. Now that's nice. It doesn't have TypeScript errors just because we don't have any in our program. Otherwise, it would also be here. Let's look at it raw and see what it's stored here and expand them. And that looks pretty much the exact same as we have here as well, except I removed white spaces. That's literally the same. It just uploaded the IDL. Okay, how? Okay, still I have questions. Let's try to answer them. So the Explorer seems to find this. It seems to somehow find it with this 5E3 account. Let's see if that's the same as this thing would do. Let's see if I can run this. npx Solana program metadata. I need to install it. Yes. So I npm installed it, and then I can directly run it. Look at that. Program metadata options command. CLI to manage Solana program metadata and IDLs. So I could say, hey, what version are we in? And then it will tell me, yes, I meant version. There. No, come on. Oh, there you go. 0.4. Great. What else can it do? Can write, create, update, fetch. That's what we're going to do. Set authority, remove authority, close, create, stuff with buffer. Okay. Fetch seems like a good first start. Fetch the content of a metadata account for a given program, just to see if the thing we just did actually uses the program metadata or if that's something else. So we fetch and then options. Wait, what's options? Options can be key pair, pair. Okay, no options. Seed and program. Seed will be IDL and program will be my demo program. Let's see. No digest implementation could be found. That's annoying. Okay, new node version. Let's try that again. Better. Now we get an account not found because it tries to access this account, which makes sense because this is probably the derived program metadata for my program for this seed. Something like get program derived address for this program, which has this pub key with the following seeds: get address, codec, encode, and address of my program, which is this, and the seed IDL. This is how I guess they come to this account. Let's check. Nope, it's yet another address. Hold on. So what am I still missing? Program key and seed. That's how I imagined that it would work. Maybe not. Maybe not. So what's that then? But it's also not the 5. It's also not this one. But while we're here, we see that it doesn't store the IDL directly. It might store the IDL, but it formatted it differently, which makes sense because you want to save space. So it doesn't really make sense to store it in ASCII. You probably encode it somehow. But yeah, not sure what this is. And maybe it's just a different way of doing things. Maybe that's the Anchor way of doing things. Maybe every Anchor program now supports that because the Anchor program stores or owns this account. So what's happening here? I want to find out what's happening here. I don't want you to tell me what an IDL is. I want you to answer my question. So there's Anchor IDL init. Anchor stores the IDL in a dedicated account on chain. So Anchor seems to do that differently. Anchor seems to do Anchor IDL and program D. And the JSON is gzip compressed and stored as raw bytes. That's what we see, yeah? That makes sense. Don't waste space. Okay, that makes sense. If every Anchor program has the code to update its IDL, then sure. I mean, that's why I'm paying so much for Anchor programs. So let's check that. So the Anchor IDL, it says, is then derived from the account itself with the seed Anchor IDL and then the program ID. Still not that. Just Anchor, also not that. Okay, program IDL file. Anchor CLI. I can build, I can init, I can fetch. Okay, let's try fetch it with Anchor. Anchor IDL fetch for this program. That works. Look, there it finds my IDL. So yeah, Anchor does it differently. This is not the program metadata program. This is just the Anchor program itself. So every Anchor program will also have the ability to store and update its IDL, which, okay, I don't know if I prefer that over one program that does it for all the programs, because then every Anchor program has the code for that, which is a bit inefficient, it seems. But sure, okay, why not? So what else can I find in Anchor IDL? Close, we can write buffer, upgrade, set authority, erase authority, build. That's what it does automatically, I think, every time I Anchor build. We have a new spec since Anchor 30. Okay, fine. Let's just play for a bit and say, I'm gonna change my program. Look, Dad, it has another instruction. And then I just say Anchor IDL build. Look, then it prints me the IDL. Do I now also have it in here? No, this doesn't. The IDL build doesn't even store it in here. But if I Anchor build, then it also stores that here. Okay, so I probably want to do Anchor build. Otherwise, I just get it in console output. And I could probably set an output file for the Anchor IDL build. But whatever. So if I now Anchor IDL, what was there again? So I can't init it anymore. I can write it to a buffer account and then set it. And upgrading does both steps, writing and then setting. So let's upgrade. Anchor IDL upgrade. Let's see what that does. Requires the following arguments, which file and which program. Okay, so file path be target IDL, my IDL for this demo program. Cool. Now it has 259 bytes and successfully upgraded. So now if I check this account again, it will have slightly more data. Is it longer? No, because I think it already has some buffer here in the end, in the sense of in case we upgrade the IDL, it's already a bit bigger. And that, I guess, is the gzipped IDL. Let's check on chain. If I would refresh that, that still looks like it has the old thing, or maybe it just didn't update that, but I don't know how often this refreshes. But I would guess that it's in here now. It does look different to last time, right? Last time we ended here at 100 with 64, and now 100 here. That's additional. There's more bytes, and also the bytes changed. Obviously the bytes changed because we have a gzip here and not the actual IDL. Now I'm not sure what I want to continue with. Do I want to continue playing around with the Anchor IDL storage stuff and understand what's in here? Or do I want to, as I said in the beginning, look at the program metadata? Although I'm not sure if that is actually being used, since Anchor does it differently. I'm not sure if anybody uses that. I could check, hold on, since it's a public blockchain. I could literally check how often that program is being invoked. A day ago. Program metadata IDL. So the Explorer distinguishes between, is it an Anchor IDL or is it a program metadata IDL? This is a program metadata IDL. So probably the IDL for the program metadata was uploaded with program metadata. That would make sense. Let's look at it raw. Yeah, it's a Kodama style IDL. And for this, hold on, maybe for this, what would be, that would be the account. Does this account exist? Account does not exist. So I'm still doing something wrong with the derivation. Where does it have that info from? It doesn't tell. Okay, let's first understand the Anchor stuff. And maybe by now they refreshed this. Nope, don't know how I can tell the Explorer to refresh this. But if I were to go to Solana and I check the Anchor IDL, nothing found. This one doesn't even find the Anchor IDL or the security IDL. This one does. Look. This one has both of them, but it also doesn't tell me where it has them from. Okay, anyway, how can I read this now? I mean, with Anchor Fetch, that does it automatically. But I first just want to understand what is here. It's an Anchor account, so most likely that's the discriminator of the account. And then this is probably something, probably the authority. Could that be? Because then here I see something that is, you know, not random. Here I have fairly clear somethings. So let's assume this is the authority, which is my authority, which is, let's quickly, just because, quick writing exercise. There we go. Look at that. So we have 93 to 63 is my hex of this authority, and that's written in here as well. So this is my authority. There we go. We got discriminator, authority, and here we had, oh, that's the old version still. So it makes me guess that was the length. We had E0, the previous length, and after the update, we have 103. So we have 16 to the power of 0, 16 to the power of 1, 16 to the power of 2. What's 16 times 16? 256. 256 plus 3 is the length of what comes next, probably. So I would assume that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6 plus 3. So we have 16 plus 3. There you go. That's the length. So this encodes the length of this, and this is then the data that actually holds the IDL, but gzipped. So I could read that and unzip it, and then I find the IDL again, most likely. Should we do that as an exercise? There we go. Then we have that as well. Okay. We still need to figure out how it's derived though, but that's the address. And then I do RPC get account info for that address. And then we have the data. Then we have the data. It's base 64. Base 64 codec. Encode that data, right? We want the bytes of it. Do you want decode or encode? Base 64 encoded data response. Wait, how do I get the... Oh, hold on. There was something with the first one. Yeah. First one is the thing, the extra data, and then it says base 64. Yeah, that's how it works. Okay, so That's the actual data then. And then from the actual data, I said the first 8 bytes were discriminator, and then 32 bytes are authority, and then 4 bytes are length. So my offset will be 8 plus 32 plus 4. I mean, I could read the length. That would make sense. So first, let's read the length. Wait, that's 4 bytes. 4 times 8 is 32. So 32 decode data slice offset plus 4. That should be the length. And then the gzip bytes are data slice offset plus 4 to offset plus 4 plus length. Let's see. Let's just log this for now. No, actually, let's log the length and then decompress it right away. Okay, you think that's gonna work? I don't think so, but I'm gonna try and call this fetch IDL. We get a CData error, but 259, that it already reads correctly. Okay. And then I think I have an error with my incorrect header. Okay, so it's not the format that it needs, is it? But let's just log the bytes just to see that we get the correct one. So we got 120. Does that fit with what we had here? So shalala, 120. Plausible. 1, 2, 3, 4, 5, 6, 7, 8. There's a 16. 8, there's a 16. So yeah, we read the correct parts. So we do read the correct bytes here. We just don't know which format it has. Maybe it's not gzip then. Nobody told me that it is that, except for NAI. So who knows about that? Yeah, you couldn't find any sources that it's gzip. Yeah, great. But you're telling me that it's gzip, you mother AI. Or mistaken assumption made by you. Okay. Fetch IDL. There you go. There we have the actual source code. So we inflate. What does that do? Where does that come from? Paco. Inflate from Paco. And then we JSON parse a UTF-8 decode. Let's try that. So forget about the G. Let's just call this deflated bytes. Then we PNPMI, whatever that is. And then we inflate the IDL. And then we UTF-8 code. So that's UTF-8. Now I'm just gonna print that. Let's see. So that's bytes now. And that looks more like ASCII actually. Or UTF-8. Same. In those numbers. It's now bigger. From the 259 we have 400, and that looks like ASCII characters. You know, those, that's an A or whatever, lowercase, some special characters like this. I think that's a line break or something like that, maybe. I don't know. 100 and 100. What could that be? Let's look at our actual IDL. DD. There you go. The 97 is the lowercase a, and that's the DD. So that, whatever that deflate does, or inflate, not actually sure what Paco does. You need types for that? Okay. Decompress data with inflate ungzip. Autodirect format via wrapper header by default. Okay, so it might be a ungzip kind of a thing. We don't actually know. Paco is apparently smart enough to decide by itself how it inflates that. Okay, so it is somehow zipped and unzipped here, but I can't tell you exactly how. Also, probably not so important, but we know the library that can use it. And now I just want the actual IDL, which from those bytes I now somehow need to get it to JSON, which takes a string, and that's bytes. So get UTF-8 codec and decode that. And then we can log our IDL. There we go. That's it. That comes from the account now. Now we have the address, that's stored in the account. And we know exactly where in this Solana account from here onwards. Okay, so we can manually decode this account from Anchor. Great. We still didn't figure out what that address is though, like how it gets to this. Maybe I still want to figure that out. And my best chance is to read source code. So IDL address for program ID. IDL address, it comes from IDL's JSON. And IDL address, look, it has the Anchor IDL and is derived how exactly? With find program address and then public key create with seed. Right. So first it does a find program address with no seeds and this program ID, and then it uses that as the base for a create with seed. Oh, that is just weird. Why do they do it like that? There is no point. I mean, that just seems stupid to me, honestly. The create with seed, this is for the system program. So basically that means anybody has the authority to do this. No, isn't that the case? Hold on. Let me try that. I mean, deterministic it is, yes, I give you that. But slightly stupid as well, because even though you use find program address, it's not actually a PDA. Okay, let's first rebuild it ourselves. So we use a find program address with no seeds as the base. Okay, so we use, this is our program, and then we use no seeds to get the PDA as the base. And then this base, we create address with seed from the following base address. Wait, no, that makes sense, because the base address still needs to sign. Yeah, I remember. We made a video about the create address with seed. And I think that the base address still needed to sign, right? For that to work. Then it's fine, because then the PDA has to sign, but the address is still created with seed with the system program. Okay, that's actually, it's fine. I take it back. It's fine. I forgot that the base address needs to sign. Because look, wait, we'll see later. The program address will again be, we created for that program, so that will then be the owning program, so that will again be our program ID. Actually, it's okay. It's actually, there's a reason why they do it like that, another direct PDA from this, because you need to go through the system program and then you can already sign with this. That's actually, it's smart. Oh, I changed my mind. It's actually smart. Now I see. It's actually smart, because that way you don't need to, I'm undecided. Is because why is that better versus just using the PDA or using the PDA with some seeds? Why do I want to have the seeds here and not here? I'm sure there is a good reason. Somebody can explain that to me. I'm still, okay, hold on, wait. First of all, that's still wrong. Here we, of course, also want our program ID. And then the seed was just one seed, and it was anchor IDL. Seeds? What's it called? Oh, you just have one seed, a string. Okay, I see. That also makes more sense for the program metadata, also does the same, and the seed is just one string. Yeah, that makes sense. Okay. That makes sense. So what I did here is, that's bullshit. It's not a PDA that is created. We actually do a create address with seed, so the system program style seed stuff. Okay, let's await this. And wait, what is it called? Call it IDL address. Let's log the IDL address and see if that would actually give me the 5E. Yes, okay. So that's how it's done. Admittedly, a bit complicated. First getting the base. So we get a PDA with no seeds for my program. Use that as the base. So this is something that we can sign for as our program. And then using this base, we create a system program account that we assign to our program with the following seed. So the seed is just to get that address. And that's still deterministic, and we cannot sign for this address directly, but we then own it because the system program will assign it to us, because we will do a create account with seed. And once you do a create account, that's in system program, Solana program system, just to quickly show you, create account with seed instruction, that thing needs the amount, the base, and the base, check this, no, the base is just an address. Hold on, new account would be the IDL account, payer would be, see, the payer needs to be a transaction sign, but I'm pretty sure that the base also needed to sign, no? How did that work? No, the base account. The base account, that must be a transaction signer. And that would in that case then be our program signing for it through CPI. So the anchor program will invoke the create account with seed for this base account. Actually, maybe I still find that transaction. I mean, can't be so difficult. This is the account. There weren't so many transactions for it. 2 hours ago, I created it. See, my demo program, it has the IDL, so it has the name, isn't that fun? Does a system program create account with seeds? As I said, that's the seed anchor IDL. That's the base address. I didn't log that, but that's the same that we got probably. That's the new address. That's who's paying, and we assign it to our program ID. And this guy, the base address, this guy is signing through CPI. It's not a signer, but it is an account because we invoke this through CPI that makes this guy a signer. Yeah, that makes sense. So only the actual program itself can do this. So yeah, it does make sense to do it that way. I still don't fully understand why we do it this way and not just create an account with a PDA. I can sign also do a create account and sign for it directly. I don't need to do it with seed, but this is how we do it. And so this is how we do it. I mean, if some of you has a good understanding of why this is better compared to doing it with the PDA directly, because I could use this PDA or derive a PDA that has this as part of its seeds. Why is that better? I don't really understand yet. But it's certainly different because for that account, I can not sign anymore. Only this system program also can't really sign for it, but it will allow me to do stuff with it with seeds. So yeah, maybe there's an advantage because we don't need to sign with it anymore if we're the owner of it. Maybe we do that such that we don't need to check with bumps or whatever, because a create account doesn't care about the bump. It doesn't care if that address, this address, is on chain or not, because it's not gonna be a PDA, it's just an address. But that argument is also kind of stupid because we will need to check the bump for this one, for the base address. So we don't really save anything here. Yeah, I don't fully understand it why that's the layout, but I think that smart people developed this and maybe it's just random and maybe it's not. Maybe it's just to make sure that we can still use that seed for our other PDA accounts and it doesn't interfere with whatever else we do in our program when we create PDAs, which could be one reason. So yeah, because if a user would for some reason choose that seed for its PDAs, then that would interfere and that's not ideal. Maybe that's the reason. I don't know, I'm just speculating here. But it also is not so important why it's the case. It's more important that we understand that that is the case and that is how it's actually done. And that is probably also how it's done with a metadata program. This is a way nice implementation though, I just see it. The way they store it super efficiently with a zeroable option where 0 means the whole account. I love that stuff. I love optimizations like these. It's just a geek like me, just that you know, nice. Anyway, compression of the data, format of the data. So this is more general, I think. But anyway, they do it with find program address and not so weird with a system program. The canonical buffer key pair is for that program ID. So that's my program with that program key and that seed. And the seed is IDL in this case. See, that's what I would have expected there to happen. And that's non-canonical, why we add another authority. That makes way more sense. It's not as unnecessarily complex with that seed. So that looks more like what I expected actually. So they do find program address with the program key and the seed, which is those 3 bytes, and the program ID. That's buffer key. So coming back to this thing, fetch IDL for my program, you would want the BZ account, which is not what you're getting here. Is it because IDL is not the correct seed? Maybe this program is not the right program ID. Let's look at source code again. So clients, JavaScript, source, commands, fetch. So fetch metadata from seed, which it has from generated. Of course. And generated. You know what? I'm gonna quickly clone. Otherwise this get a bit annoying. So fetch metadata from seeds. Program, authority or null, and seed. So I provide IDL and the program. And what does that do then? It does a maybe, which find metadata PDA with seeds and program address, which here. So we do have that program address. That I think we have correct. Yeah, 7s. 7s, okay. And then we get program derived address for that program address with the following seeds: the address encoder of the program, then an option encoder, and then a seed encoder. The seed encoder is a fixed encoder size. Okay, so we have a fixed size of 16. Well, you gotta know that. That changes stuff. So it's not just the 3 bytes, it's the 3 bytes inside 16 bytes. Prefix null encode this. So I have no prefix for an option encoder. I'm not sure if the address is none, if it then puts anything here or not. Okay, let's try. But yeah, this does change stuff. So instead of this, I need to get a fixed decoder size of a UTF-8 encoder and then encode my IDL string. And if I then find PDA, there we go. Now we get the BZ, which is the account it expects. So yeah, this IDL string seed is with a fixed length of 16, even though it just needs 3 bytes of the 16. But you still need to add the zeros. You know, that's, I'm just gonna show you this. That's what that part of the seed looks like. So we just have 3 bytes IDL and then remaining zeros, 16 bytes. And that makes a difference if you have those zeros or not. That's why that is a different address. Okay, so that's, you gotta know that you just got a seed in source code because that's not standing anywhere. Okay, fine. Yeah, seed length is probably the thing. SPR program metadata state seed length. Yes. Yeah, seed length. There you go, 16. The length of the seed used to derive metadata account address. Okay, sure, good. And then, you know, we could analyze what's exactly in there. We have the header and the data, and the header consists of, so the header has a discriminator, which is just a U8. We have the program ID, we have the authority, whether or not it's mutable, whether or not it's canonical. The seed is also stored in the header, the encoding, compression, format, data source, and data length. Interesting. And here we have account discriminator, empty buffer or metadata account. So we have a buffer account or a metadata account really. Encoding can be UTF base 58 or base 64. Compression can be none, gzip or setlib. And probably gzip or setlib, that's probably also what Anchor does. One of those. Format, JSON, YAML, TOML. Interesting. Cool. Anyway, should we quickly do that as well now? Let's say we had another program, a big demo, and we add Pinocchio here. So just a simple Pinocchio program, and then cargo SBF every time. There we go. And then we could Solana deploy, target, deploy, pick demo. Wait, what? Oh, Solana program deploy, sorry. That should be fewer transactions, yes, 4 transactions. And we have the following program, H9, because I was too lazy to get myself my own custom thing for that, but I am still the authority. And we don't have any security TXT or IDL or whatever. Look, but here it suggests that we should use the program metadata write security JSON. So yeah, let's start with that, such that that's done. What's the format of a security JSON? Follow the documentation. There, let's do a security TXT with name, Pinocchio, demo, program, logo, whatever, description, notification, SDK. I don't think I need all of that. Contacts would be good. Email, solandy at Discord, Solandy, Twit, that's public. Policy, preferred language. Oh, look, English and German. Yes, exactly. Encryption, nah, I don't have that. Source code, I don't have that either. Release, revision, auditors, no auditors. Acknowledgements, I actually stole this from somewhere. Expiry, version, yeah, whatever. So let's say that was my security TXT, and then literally as they suggest here, I'm gonna say security JSON. Nope. Oh, I called it TXT even though it's a JSON. Yeah, maybe call it JSON. If it's a JSON, might as well. JSON. JSON. There you go, that's better. JSON. There you go. Writing metadata account. That's the metadata account. That's the program, and that's the seed. Success. Seed is security. So let's actually check if that would match here. If I would say security here for this program, would that give me the 23i? That would give me the 23i. Yeah, that's the same account that was actually created here. Nice. So that's how it's derived. And now that we uploaded this, still doesn't find it. Maybe that just takes a bit. But I think that account should be here now. Writing metadata to this account. Check this account. Does exist. It has some bytes. 2 minutes ago. Yeah, I'm gonna give you some time. Meanwhile, I'm gonna check that account. It's fully packed, so that's nice. There's no buffer in the end. No free space in the end. It is a metadata account because the first byte is a 2, 0 for uninitialized, 1 for buffer account, 2 for metadata account. And then that's the rest of the header where I'm like, yeah, that all means something. Do you want to check what it means exactly? So the program, first is the program. So that's the program ID, the H whatever. Then authority. For canonical metadata accounts, the authority can be none. Since it's a canonical, this is none, okay? And then we have 1 for mutable, 1 for canonical, and then we have the seed. That's the seed. Those 16 bytes. Interestingly, that's lowercase letters. Oh, yeah, because that's hex. It's not... Yeah, it's hex. It's not ASCII byte values, it's hex. But yeah, that's security. That's the seed. It's also here. And the remaining 0 bytes, because it's the seed length is always 16, as we found out. What's next? Encoding. So I would need to check the encoding and the compression. Both encoding is 1, compression is 2. So encoding is UTF-8, compression is setlib, and then comes format and data source. Format is 1, so it's JSON, and data source and data length. Data source is 0. I think that's where we are. So data source is direct, so we store it directly, and that might then already be the length. Data source direct, and then the length. So that's 4 bytes in length. And then we still have padding, 5 bytes. To start at the 8-byte boundary. That makes sense. Okay. So that's the length. Yes. And then we have 5 bytes of padding. And then we start such that we start cleanly here at the beginning at this 8 bytes and not somewhere here in the middle. Or wait, here. So we have 5 bytes of padding. So that's the length. So that's 256 we said plus 2. So it's 16 down. And 2 to the right is our length, so that's the actual data. Here we go, we understand what's in this account. Nice. That's the security TXT. And we know what's the encoding, and same way we could now decode that. Should we try and decode that? 1, 2, 3, 4, 5, 6. 6 times 16. Let's fetch security and already reuse that. So we derive our security address, and then we get account info for that address. And our offset is 6 times 16. And then we just slice. We don't decode, we just, we don't even read the length. I could, but I know that this account is packed efficiently anyway. So I can just say, give me my offset and then go to data length. So that should also work. And then we do the same thing where we inflate it with that Paco. Inflate and hope that that knows what it's doing. Now we just have the security thing here. So let's fetch security from this account. And will it manage? This is taking longer than I thought. Probably some bug. Oh, no! Look! It managed! It just took a while to get the account info. Maybe definitely is just slow. But here, look, that's my security TXT with the email that I'm not going to give you. I mean, I give you my email. It's easy to find out. It's just not that easy. Nice. Cool. And the Explorer, I'm not sure why it's not displaying that here, because I literally did what it told me to do here. And it worked. Like, it's on chain. The data is here. And it works the same way with the IDL as well. Should we build a quick IDL? Just quickly manually gonna write an IDL for the pic demo IDL JSON. This is my program ID. There you go. That's my IDL. It has a pub key. That's all it has. It has an address and no instructions, nothing. That's my program. Feel free to call it. And then I could do all of this manually with actual source code, fetch and parse metadata content. Because that's there. I could just use that package. That it has the generated stuff that I can do this. I just did it manually here, the decoding, just for practice. And also the uploading it, I could also do that. But I'm gonna do it with this CLI. I write the IDL for this program, the IDL JSON. Metadata AHA, operation executed successfully. So if I would now fetch this IDL, so instead of security I say IDL, then the naming is not correct anymore, but whatever. Fetch IDL, and look at that. Then it fetches me this IDL with the program metadata. So that's it wrote that correctly to the account, to this account, the AHA, as we saw here. And does the Explorer show me that though? Will it find the program IDL? No. But also maybe it just takes a while until it finds those. Not sure. Hi, me from the future here. It did load my IDL now. It doesn't properly show it, but it is uploaded and the Explorer finds it as well. It probably just expects the instructions and everything, but it's there now. It just took a while for the Explorer to also have it here. And also the security TXT is included. Look, this is self-reported by the author and might not be accurate. A Pinocchio demo program. Yeah, so we have the security TXT here. This is not actually my email, but this is my Twitter. You're welcome. So the point here is it just needs some time for the Explorer to actually display this. And I think I'm okay with that. I think I can end it here. We did have a look at a lot of things today, how the program metadata program stores IDLs and security TXT, basically any kind of metadata that you want to store, but the security and IDL are the two things that the documentation says. I would say that's good enough for me. So we did have a look at the program metadata program. We also had a look how Anchor does it without any other program. So it seems like every Anchor program supports uploading the IDL directly with the Anchor program itself. That's new. I didn't know that. And then there's also the program metadata program, which also supports the same thing and is also really nicely, efficiently implemented. I like that. I wish more people would upload their IDLs. But yeah, it's nice knowing how we can do that. And it's super simple. Like with a CLI, you can just upload your IDL, upload your security TXT. And we had a look how it's actually stored on chain, such that we know how we can query that and make sure that it was uploaded there properly and stuff. So yeah, I think that's something that every Solana dev should know about. And I do encourage all of you to upload security TXTs and your IDLs. Just makes it simpler to work with your programs. Unless you don't want people to work with your program, then okay, fine. But for being more interoperable, is that a word? For increased interoperability, also a difficult word to say, you might want to add your IDL such that other devs have an easier time integrating your program in their solutions. So yeah, cool. I think I'm good with that. Is there anything else that I need to say on this? I don't think so. It was a good journey understanding how IDLs go on chain. I never really looked at that. And there's probably more nuance to it. And of course, we can look at it further and we can implement our own solutions. We could have a deeper look into how we use it in TypeScript, in our code, how we can, write our own code that uploads IDLs and stuff. But it should be fairly self-explanatory. Just use the Solana program metadata, create and npm package, and you'll be fine. Should be self-explanatory. Yeah. And with that, I release you to one of my next videos or anything else that you want to do around here or anywhere else on the internet, or I don't know, go out, touch grass. But before, give me a like and subscribe if you haven't done that yet. And then I'll see you in the next video. Yeah, we keep on learning.